Now that we have an understanding of what it means for a function to be continuous, we're now ready to look at a very important theorem in calculus called the intermediate value theorem. And so the reason why it was important for us to understand continuity before we talked about this theorem is that this theorem requires the function to be continuous on the interval in question. If we have a function that's continuous on a closed interval written as AB, because it includes the endpoints A and B. Throughout calculus, we're going to see that continuity allows us to make powerful conclusions about a function, even if we don't know what the graph looks like. If we know it's continuous, there are already some conclusions that we can draw from just knowing that. Okay, so first, let's think about intuitively what the intermediate value theorem means. Okay, and then we'll look at it officially and read it. A function that's continuous and the graph is smooth from one point to another, so it doesn't skip over any points or it doesn't have any jumps or holes or asymptotes. It connects from one point to another without any skips. Okay, so if the function starts at one value and ends at another, it starts at point A, ends at point B on our closed interval, then it must take on every value of the y value, the dependent variable, between those two values. So think of the analogy like driving up a mountain. So if you're driving up a mountain, if you start at an elevation of, say, like 500 feet, and when you finish driving up this mountain, you're at 2,000 feet. And so because you're going from 500 to 2,000 feet, you have to hit every single elevation on the way up. There's no skipping an elevation. You'll hit every elevation on the way up. So, for example, you can't skip over 1,000 feet or 1,500 feet if you're driving up a mountain for that elevation. You go continuously from 500 to 2,000 without skipping any of those intermediate elevations. So continuous functions behave in that same way. You can't jump or skip over y values. Okay, so let's now look at the intermediate value theorem now that we have that analogy in our head. So it says, let f be a continuous function over a closed bounded interval, a to b. So those are our x values. We're going from a to b. So here's a mark it here, from a to b, okay? And if z is any real number between f of a and f of b, so here's f of a, here's f of b. If we have any y value labeled z in between the two corresponding y values for a and b, there has to exist a value for x at that point, and they're labeling it as c. Because if I'm driving along this mountain from point A to point B, I'm hitting every elevation on the way up because it's continuous. There's no holes or jumps or asymptotes. There's nothing breaking it up. So I have to hit every single value on the way up. So that's what this is saying. If I pick a value of y between f of b and f of a, there has to exist a value for x between a and b for that value of y. So now let's look to see about how we can apply this intermediate value theorem. Okay, so this question says, f of x is continuous, and that is the main idea that we want to make sure, if we're going to use the intermediate value theorem, that it's got to be continuous over the interval in question. Okay, so we have an interval of some function from 0 to 2. So I'm going to draw some generic graphs. So here's my x-axis. I have x is 0 here. Here's 1. Here's 2. Okay, it says f of 0 is greater than 0, meaning the value of y is positive at 0. So we have some positive value at f of 0. So it's above the x-axis because it's positive. And then at f of 2, we have a negative y value. So then we have here at 2, we have some negative value down here below the x-axis. All right, so because it's continuous, it has to hit every value in between because there's no holes or jumps. So you might have something that looks like this. Okay? So the question says, can we use the intermediate value theorem to draw a conclusion about the zeros of f of x on this interval from 0 to 2? So here's our interval that we're looking at from 0 to 2. We're looking at this graph of the function. Now, because the function is continuous on the interval from 0 to 2, we know that there are no holes, no gaps, jumps, asymptotes, no kind of skips at all. Okay, so if I draw a value from a positive number, we don't know what the positive number is, but we just know it's above the x-axis. So from the positive number down to the negative number, it absolutely has to cross over the x-axis because there's no skips or jumps or anything like that. So we can say, because f of x is continuous on the interval from 0 to 2, and because f of 0 is positive and f of 2 is negative, then there must be at least one 0 because it has to cross over the axis at some point. Now, it could cross twice. We could have something, if I pick a different color, let's pick red. Maybe the graph looks like this. We just know the starting point is positive and the ending point is negative. So it has to cross at least once. It could cross more than once. It could also be that f of 0 is negative and f of 2 is positive, in which case it would just flip-flop. The points would go flip-flop over the x-axis, but it would still have to cross the x-axis at some point. So if we have a y value that's positive, a y value that's negative, and we know that the function is continuous between those 2 points, then it has to cross the x-axis. So the intermediate value theorem can help us determine on what intervals we have zeros. All right, let's look at the next example. It says we have a function f of x, which is 1 over x. So the graph of 1 over x, the sketch, this is just a sketch, looks something like this. And there's an asymptote on the y-axis. All right, now it tells us in this question that f of negative 1 is negative 1. So we have this point here at negative 1. Negative 1. Then we also have the point at 1, 1. So when x is 1, y is 1. So we also have this point here. Now it says, can we conclude that f of x has a 0 on the interval negative 1 to 1? Well, if I look at this interval, here's negative 1, here's positive 1. If I look at this interval from negative 1 to 1, there are no zeros. But here's the thing, we cannot use the intermediate value theorem here because the graph is not continuous on the interval from negative 1 to 1. There's an asymptote at x is equal to 0. So there's going to be a skip there. There's no value for y when x is 0. So this is a key point that the function has to be continuous on the interval that is in question in order for you to draw any conclusions using the intermediate value theorem.